Good morning, everybody. Um, I had my iPad doing the reset loop every 5 minutes, which is why yesterday your Edpuzzle video was something that I pulled off of YouTube. I'm hoping that from now on, your Edpuzzles are going to be me actually speaking and me showing you something. The only other problem that I'm having is my printer is out of ink. So I'm hoping that for the rest of however long we need to do this kind of e-learning, I'll have the notes that we would do in class like this, but unfortunately right now I'm stuck doing everything by hand until probably Thursday when I can get some printer ink. Right now we're going to move on from what we talked about yesterday in that Edpuzzle, talking about different kinds of angles, different things being congruent. Right now, if you look here, I've got a lot of definitions off to the side here. And I have this picture of a couple different lines and angles. Each one of these words represents something happening over here in this picture. To get started, parallel lines. We've talked about that before. Parallel lines are lines that are never going to cross. An example of lines here that are never going to cross are lines A and B. This line here and this line here. If I extended them, they're never going to cross at all. So I can write that two parallel lines would be A and B. New word, transversal. That's a line that intersects or crosses through two or more parallel lines. So I know that these two lines are parallel, A and B. If you notice, I have this diagonal that's crossing through them. That's going to be a transversal. I'm going to call that line C. So the transversal here would be C. These are parallel. This is crossing through it. From here, we have some different names for different kinds of angles. That's what these numbers are inside of the lines. So first thing, we have alternate interior angles. Alternate meaning that they're alternating, as in they're going from one side to the other. Inside meaning, or interior meaning that they're going to be towards the inside of the line, not the outside. An example of this, if you were to think about each one of these as an angle, would be something like 2 and 6. So for example here, I have angle 2, which is this acute angle here. I have 6, an acute angle here. If you notice, they're making the same angle, they're just doing it on different parts. They're both inside the lines. If I were to put my fingers here, if I looked out here, this would be the outside of this line. If I looked on the outside here, that would be the outside. This is inside both lines. So that's why they're alternating. They're on each side. One's on the left of this line, one's on the right side. Alternating, interior, and they're the same. So alternate interior angles, an example would be angle 2 and angle 6. Another example, though, would be 3 and 7. They're also inside these lines. One is on the right side, one is on the left side. So I can call that angle 3 and angle 7. It doesn't matter which order you put these. You could have put angle 7 and then angle 3. You could have put angle 6 and then angle 2. The order doesn't matter. You just want to make sure these are paired together and these are paired together. And remember, they're the same measurement. 3 is obtuse, 7 is obtuse. That's why they go together. 2 is acute, 6 is acute. Alternate exterior is the exact same thing, except now we're looking to the outside of these lines. So that's like angle 1, angle 8, angle 4, angle 5. Angle 1 is obtuse. It is on what would be the top or the left side. Going down here, 5 is on the bottom or the right. So I would say an example of alternate exterior would be angle 1 and angle 5. I could also say the same thing about angle 8 and angle 4. They're both on the outside of these lines. One is underneath, one's on top, and they're both acute. So I'm going to call that angle 4 and angle 8. Corresponding angles are angles that are in the exact same place. So what that means is they're both like mimicking, where if you think about this as one line and this line being the same because they're parallel, 1 and 3 are in the same position. Out of these 4 numbers, they're kind of in the top left. 7 and 5 are both on the bottom and they're both obtuse. 2 and 4 are to the left. 6 and 8 are to the side. So I can think about things being corresponding as angles like angle 1 and angle 3. I can also think about that as something like angle 6 and angle 8. There's more of them, but these are just some examples. Here are just some things to keep in mind that are going to make it easier to answer future questions. If two parallel lines are cut by a transversal, which means we have two lines like A and B, and they're cut by C, corresponding angles will have the same measurement. Alternating interior angles will have the same measurement, they'll be congruent, and same thing with alternate exterior, they will be congruent. So what that means is if I went back here and let's say that angle 1 was worth 150 degrees. 7 and 1 are going to be the same measurement, 150 degrees. I could say the same thing about angle 3. If you notice, all of the larger angles, the obtuse ones, are all going to be 150. If you remember from the other day, straight line makes 180 degrees. If this is 150 and I need something to make this 180 total, I would do 180 minus 150, and I would get 30 degrees. So if this is 150, this would be 30, this would be 30, this would be 30, and this would be 30. If you notice, I've only got two numbers for every one of these answers. I've got 150 or 30. The nice thing about this is even though there's a lot of angles to figure out, you're only going to be using two different numbers to solve them.